And here we go with ionic nomenclature. So now that you know how to write ionic formulas, let's talk about how to state our names. So how do we name binary ionic formulas? And binary just means, two. Like if I have this guy or this guy. So this is two elements bonded together. That's two elements bonded together. It's an ionic bond because one of them is a metal and the other one's a non-metal. So how do we name those? There are a couple of rules to it that I'm going to give you here. Okay, so there are two steps to this. The first element in the name, the cation, gets its name directly off the periodic table, and the name for the second element gets an ending change. And so whatever the ending of it is, like if it's chlorine, usually the ending is INE, something along those lines, you're going to change it to IDE. Now usually the last syllable in the element, for example, phosphorus would be phosphide, is going to get changed to IDE, like sulfur will become sulfide. And it's not always a perfect system. It doesn't always work out. So that's why practice and getting yourself familiar with how the endings change can help you out. Okay, so the next one here is, what's the name for this compound? So here I have the first element getting its name, sodium, and the second one, which would normally be bromine, is going to be bromide. And the number 3 here, what's the name for this compound? Well, the first one is aluminum. So the first element is aluminum, and the second one is sulfur, so we have aluminum sulfide. And number 4 here, CaO. First element is calcium. The second element is oxygen, so we have calcium. Instead of it being oxygen, it's oxide. Alright? Okay, and that's when they are binary. Now moving on to the tertiary ionic compounds. Those are right off the polyatomic ion sheet. Polyatomic ion sheet. So these are the ones that you hope show up on your test because you take them directly off of that sheet. So you're going to need your polyatomic ion sheet, and those have a set of rules too. Alright, and those two rules are the first element, which is, the metal, is going to get its name directly off the periodic table, and the second set, or the cation, the anion, is going to get its name directly off of that polyatomic ion sheet, or your oxidation sheet, the list that's on the back of your periodic table. Okay? So the hardest part about this is that you're going to have to identify what the actual polyatomic ion is in the formula, because it can be a little tricky. But for the most part, it's going to be a metal followed by the polyatomic ion. All right, so turn your sheet over and let's do some of those names. All right, so this first one here might look a little familiar. It's lithium followed by its polyatomic ion. So we write lithium, and then we look up that polyatomic ion, and it is acetate. So that is lithium acetate. All right. Number 7, we look this up. The first element, the cation, is magnesium, and then we look at our polyatomic ion sheet to find SO4, and SO4 is sulfate. So this is magnesium sulfate. And we look at the next one here, number 8. I have K2Cr2O7. So my first one, my cation there, that is potassium on the periodic table. And then I look up Cr2O7, and that is chromate. It's hard to read. Dichromate. Dichromate. Right there. Okay, so that is our tertiary compound examples. Now, if you have a multivalent, also known as the transition metals, everybody in the middle of the periodic table, those guys, they have multiple charges, right? And they have Roman numerals that show you what their charge is supposed to be. So if it's multivalent, the first thing that you should check is if your first element is a transition metal. Alright, so basically, if it falls, this is your periodic table, and it falls somewhere in here, then it's a transition metal, and it could be multivalent. It could have many different charges. And before you write the Roman numerals, you need to figure out what charge it had, or what Roman numeral it's going to have. So how do you determine the charge of that metal? And you basically have to crisscross the formula. So let me tell you what I mean by that. I need to uncrisscross this. So this element, the first element, tin, and then the second one, nitrogen here, I have to take those charges, if it's SN3, N2, I basically have to take those charges and bring them back up top. That will let me know that this was SN2 plus, and nitrogen had the 3 minus charge. So I had to uncrisscross the chemical formula to get the charges. Okay, and that lets me know that this was tin with a positive 2 charge. So I have tin 2 nitride. Alright, the Roman numeral 2 symbolizes the charge that was on tin. Let me rewrite. Okay, so tin 2 nitride. And remember, the second one is going to end in IDE. Same one over here. So here we have tin again, and the second one, which is phosphorus. Now, the first thing I've got to do is, because I've got a transition metal here, is uncrisscross the charges. Phosphorus is in the column where I know that it had a negative 3 charge. And then this is a 1-to-1 ratio right here. So that's how I know that this tin had a positive 3 charge, because it's 1-to-1. Phosphorus is always going to have the same charge, right? It's in the nitrogen family column. It's in the column that's a 3 minus. So it's always going to have that charge. That charge was there. So this was something that was swapped and dropped and then simplified. All right. So now I'm going to have to, now that I know what the charges were, because they were kind of hidden, I have to write the formula here. So I have tin. This is tin 3. And it's no longer phosphorus, which it is on the periodic table. It's phosphide. All right, so here's another one. This is tin, and we have chlorine. I look on the periodic table, column number 17, which is where chlorine is, had a negative 1 charge. Right, so that explains that little 1 that should be right there. So I know that that 4 came from the tin. So this is tin 4, and it's not chlorine, it's chlorine on the periodic table, so it's tin 4 chloride. Okay, let's do a couple more. Here I have this compound right here, that's iron, and that's oxygen. This is iron on the periodic table. Alright, if I uncrisscross those charges, that 3 was up there, and that 2 was over there. So this is iron 3 oxide. Alright, Now I have another one. This is interesting. I've got a transition metal and a polyatomic ion. So I've got somebody who needs a Roman numeral, and I've got somebody else who's directly off your sheet. So you're going to need your periodic table for this. So first I have to find this guy on my polyatomic ion sheet and uncrisscross the charges. So I look up SO, and SO4 was sulfate, or I'm sorry, is sulfate, and it has a -2 charge. And I have copper over here. Now, this guy is stuck together, right? And here we have, again, we have a 1-to-1 ratio. So that tells me that that was copper with a +2 charge. So I have copper 2, and then for this guy, I just look up his name on the periodic table, and it was sulfate. Okay? Alrighty, so moving on to the next one right here. And I've got a zinc and a chlorine. So the first element gets its name, zinc. This guy is a transition, right? But he's one of those guys that don't normally get Roman numerals. Why? Because he only has a +2 charge, and it's one of the exceptions, much like silver. So we know that it's a +2, so we don't always write the Roman numeral 2. So that's where that 2 came from, was right there. And of course, chlorine had a -1, so we just say zinc chloride. Okay. Okay. You should check to see if your first element is a positive polyatomic ion. And if you have a positive polyatomic ion, what should you do? Your positive polyatomic ions are the ammonium ion, and the hydronium ion. And the hydronium ion is probably also on your sheet, and that is H3O. It's got a +1 charge. So both of these positive polyatomic ions have a +1 charge, and you have to be able to recognize them and pull their name directly off of that sheet. I'm going to look at this first one here. So here we have NH4, which is ammonium. And then we have CO3, and if you look on your sheet, CO3 is carbonate. So this guy here is ammonium carbonate. And we'll look at the next one. I have NH4 again, so I have another ammonium. And the second one here is an element. And so the first one gets its name, and the second one ends in IDE. So that is sulfur. So I have ammonium sulfide. All right. And then here I have H3OCl. So that is a chlorine. So I know that that's the anion. And so there is my hydronium. And so you just look up that on your polyatomic ion sheet. HYDRONIUM. So it's hydronium. That's the cation part. And H is also a positive cation too. So this is a tricky one. And then it ends the anion, and this one is the chlorine, and we don't say chlorine, we say chloride. So that is hydronium chloride. Perhaps now you can get my ionic jokes. Why do chemists like nitrates so much? Well, because they're better than day rates. And all of Miss Hoskins' students are all cations because they are positively awesome. I just find all cations so positive.
And isn't it ironic?